Hi everybody, this is Mr. Beckstrom, and today I want to take a look at one of the exercises from the book. This is on page 609. It's number 39. It was part of the assigned review for this test. And it says find ZW and Z over W. Both of these are using the polar form of the complex number here. So these are in polar form, and they also want us to leave our answers in polar form. So I went ahead and I copied over the formulas when you multiply two complex numbers together and when you divide two complex numbers. So the nice thing about these being in polar form is that it is really easy to find the radius and the angle. So I'm going to go ahead and mark that down. So there's 2 here. Call that our radius 1, and the pi over 8 will be our theta 1, and then for the second one, for W, the 2 will be our R2, and the theta we'll call that our theta 2, just to match our formulas over here. So the first one, and really we're doing Z times W, so this is just a generic equation or a formula there. So we're doing Z times W. So that's going to be equal to R1 times R2. So that's going to be 2 times 2. And then in the brackets here, we're going to have the cosine of theta 1 plus theta 2. So that's going to be pi over 8. Pi over 8 plus pi over 10, plus I sine of the same thing, pi over 8 plus pi over 10. All right. And then all we need to do is simplify that. So this is going to be equal to 4 on the outside. And then on the inside, we're going to have the cosine. So really I'm going to go ahead and use my calculator for this. And for pi over 8 plus pi over 10, it's really adding the two fractions 1/8 and 1/10. So what I can do here is just do 1 over 8 plus 1 over 10. And then I'll get an answer. I will then convert that to a fraction, so I get 9 over 40. So that's going to be the cosine of 9 pi over 40 plus I sine 9 pi over 40. So cosine of 9 pi over 40 plus I sine of 9 pi over 40. And that is it for the first part of this. Now for the second part, Z over W, using our same formula, that's just going to be R1, which is 2, over R2, which is 2, times the cosine of pi over 8 minus pi over 10, pi over 8 minus pi over 10 plus I sine of pi over 8 minus pi over 10. Remember, these should be the same angles once we do our subtraction and our addition up here. We should have the same angle for both the cosine and the sine. Close that up, and to simplify that, just have a 1 on the outside, so this will end up being the cosine. And once again, now I'm going to do 1/8 minus 1/10. So let's do 1 over 8 minus 1 over 10. We could always do this by hand, but we have a calculator. Convert that to a fraction. That's 1 over 40, so this is going to be the same as pi over 40. So pi over 40, and let me just double check on that. Yes, plus I sine of pi over 40. And that's your final answer. And this is what we're pretty much going to be doing with all of these types. Now, there are a few here that are given to us in the A plus BI form. So if they're given to us in the A plus BI form, like for example, if I'm just going to do a quick example here, let's say z is equal to 3 plus I and w is equal to 2 minus square root of 2I. Let's say we had something like this, then it's not as quickly apparent what the R1, R2, theta 1, and theta 2 are, so we have to use the formulas. For z, the radius, so the R1 is just going to be equal to the square root of this squared plus this squared, so 3 squared plus 1 squared, and this would be equal to the square root of 9 plus 1, which is the square root of 10. So that would be our R1, our R2. We're going to use the same formula, but this time we're going to be using these two values, so 2 and negative root 2. So this would be 2 squared plus negative root 2 squared, and that's going to be 4 plus 2, which is 6, so we get the square root of 6. And then for our angles, we can use the inverse tangent of y over x or b over a. So I'll just do the first one here. So the first one would be the inverse tangent, or theta is equal to the inverse tangent of this over this. So that would be 1 over 3 for this first one. And then we just go to our calculator and make sure that we're in the degree mode here. Alright, so it's a lot easier to tell these angles in degrees than it is radians. And I can do the inverse tangent of 1 over 3. And so that first angle would be about 18.4 degrees there. And then we can do the same thing with the second theta as well with this. So it would be the inverse tangent of 2 over negative root 2. Alright guys, I hope this helped. If you have any questions, please let me know, and good luck on the test. Thanks.